For half the year, an invisible wall of air sits directly above North India. It behaves like an impenetrable barrier, keeping the region bone dry and locking out any moisture from the surrounding oceans. This barrier is the subtropical westerly jet stream, a massive high-altitude wind current. As it flows toward the subcontinent, it hits the Himalayas and splits. The southern branch sweeps over North India, creating an oppressive dome of heavy, high-pressure air. This dome acts as a physical lid. Because high pressure forces air to descend and stay still, it spends the winter bouncing incoming rain clouds away from the land, leaving the skies perfectly clear. But as the summer sun bakes the northern hemisphere, the Earth's global pressure belts begin to slide northward, pushing the entire atmospheric system out of its winter alignment. Eventually, the system hits a breaking point. The southern branch of the jet stream snaps completely north of the Himalayas, instantly evaporating the high-pressure shield. This sudden removal of the atmospheric lid triggers the monsoon burst. Instead of a slow gathering of clouds, ocean air explosively rushes in to fill the vacuum the moment the barrier disappears. The force driving this billions of tons rush of water is the Tibetan Plateau. During the summer, this vast barren expanse of rock absorbs incredible amounts of solar heat, turning the entire plateau into a massive thermal engine. This heat creates a low-pressure void, forcing hot air vertically. It hits the tropopause, travels thousands of miles south, and crashes onto the Indian Ocean near Madagascar, creating a high-pressure zone, the Mascarene High. This heavy air recoils, scooping up massive amounts of moisture from the warm ocean surface, and accelerates back toward the low-pressure void waiting over India. Meteorologists call this upper atmosphere cycle the tropical easterly jet. It is the geographic engine that hurls moisture at the subcontinent with incredible velocity. This initial assault is the Arabian Sea branch, a dark wave of moisture that makes first contact along India's western coastline. When these winds collide with the western Ghats Mountains, the air is forced upward. This triggers orographic rainfall, heavy precipitation caused by mountains, which sustains the dense, lush green canopy seen in these hills. Rajasthan remains a desert because of a simple geometric fluke. The Aravalli Mountains run perfectly parallel to the incoming wind, so the moisture slides right past, without ever being forced upward to cool and turn into rain. While the west is being drenched, a second, more volatile wave, the Bay of Bengal branch, moves into the northeast. These winds enter a geographic trap in the Garo Hills known as the funneling effect. A wide mountain entrance pinches into a narrow canyon, squeezing massive amounts of moisture into one tiny area. In Mawzinram and Cherrapunji, these bottleneck clouds dump over 11,000 millimeters of rain a year, the highest totals recorded anywhere on the planet. The contrast between India's rainforests and its deserts is determined entirely by the angle of its mountains against these two ocean currents. While the monsoon arrives with a burst, it leaves with an agonizingly slow withdrawal. As global pressure systems drift back south, the moisture-pulling engine begins to decay. This transition leads to a phase known as October heat. The rain stops, but the air remains saturated with moisture. Since our sweat cannot evaporate into such humid air, the temperature feels significantly higher than the thermometer suggests. As the winds finally reverse and head back toward the sea, they pick up a final load of water, slamming into the Coromandel coast of Tamil Nadu. This retreating monsoon acts as a vital geographic equalizer, delivering water to southern regions that were bypassed during the initial summer rush. By winter, the cycle is complete. Look at these jagged snow peaks. The high-pressure shield of the subtropical westerly jet has dropped back down across the Himalayas, locking North India into another dry season. Yet, an anomaly remains. Deep in the winter, unseasonal rainstorms often hit the north, just as the wheat crops are ripening. These storms originate thousands of miles away in the Mediterranean Sea, where temperate cyclones form in the winter months. These storms surf the subtropical westerly jet, traveling across the Middle East to crash into North India as western disturbances. The Indian monsoon is the climax of a ceaseless war between global wind currents, shifting ocean temperatures, and the orientation of mountain peaks.